Assalamualaikum and good day. I'm BINTI LAILI, a student of Faculty Health Science from Universiti Kebangsaan, Malaysia. I will present to you my study entitled Chloroquine-Induced Lysosomal Dysfunction Increased Amyloid-Beta Expression in Human Brain Endothelial Cells. To begin with, decline in cognitive brain function represents one of the main health challenges of aging, known as neurodegenerative diseases. Alzheimer's disease is one of the most common type of the disease that affect elder population aged 65 and above. According to Alzheimer's Association, about 50 million people suffer from Alzheimer's disease worldwide, and 10 million new cases are recorded each year. Alzheimer's disease are characterized by progression of symptoms that hinder performance of daily activities, which include memory loss, impaired communication, difficulty in walking and swallowing, as well as behavioral changes. Neurodegenerative diseases are related to deposit of protein aggregates. Like in Alzheimer's disease, deposition of amyloid beta peptides that are generated from the cleavage of amyloid precursor protein by beta secretase and gamma secretase is known as the main neuropathological hallmark. Deficits in amyloid beta clearance play pivotal role in Alzheimer's disease progression, and its aggregation could cause disruption in brain endothelium that will contribute to the vascular dysfunction. Lysosome is a primary degradative organelle in cell that function to degrade any macromolecule or organelles that are damaged or aging. It is known as the terminal nexus for crucial degradative pathway, which are autophagy and endocytosis. The degradation of lysosome is important in maintaining cell homeostasis. Its dysfunction will negatively affect autophagy degradation pathway, and impairment of lysosome function has been said as one of the primary contributing factors that cause to the deposition of amyloid beta aggregates in brain. However, it is still not clear how lysosome dysfunction is related to vascular dysfunction in Alzheimer's disease. Therefore, the aim of this study is to observe the role of lysosome dysfunction in Alzheimer's disease in terms of amyloid beta expression. A commonly used lysosome inhibitor, which is known as chloroquine, is used to treat human brain endothelial cells. Chloroquine is a weak base that accumulate in acidic compartments such as lysosome and will cause alteration in lysosome pH. Chloroquine that induce lysosome dysfunction will block fusion of lysosome with autophagy vesicle, which is known as autophagosome, and will thus impair the degradation system of autophagy pathway. Method of this study include culturing human brain endothelial cell HBEC5I cells in pre-coated flask with 0.1% gelatin, followed by an MTT assay to examine the cytotoxic effect of chloroquine on HBEC5I cells, as well as to establish dose. And then automated microcapillary immunoassay was conducted to confirm lysosome dysfunction by measuring lysosome and autophagy markers expression, which are LAM1 and LC32. Enzyme-linked immunoabsorbance assay or ELISA is used to observe the amyloid beta expression, and for statistical analysis was conducted by using GraphPad Prism. Based on the MTT assay result, chloroquine is a dose-dependent compound toward HBEC5I cells in which the cytotoxic effect increases with increasing concentration. At 12.5 micromolar, the viability of cells started decrease and was significantly reduced at 200 micromolar, and IC50 value was obtained at 125 micromolar. In order to establish dose, an optimal chloroquine concentration that did not affect cell viability is needed. Therefore, value of IC10, which is 17.5 micromolar, and IC25, which is 70.5 micromolar, along with 125 micromolar, was performed in the subsequent experiment at similar time point for 24 hours. Cell morphology was observed under inverted light microscope. At low concentration of 17.5 micromolar, there were no morphological changes was observed. Meanwhile, at 70.5 micromolar and 125 micromolar, clear vacuole formation in cytoplasm were observed, as well as cell shrinkage, which is more prominent at highest concentration. Lysosomal associated membrane protein 1 is a major component of the lysosomal membrane. Hence, it is an appropriate marker to measure the integrity of lysosome. Based on the densitometry analysis, the band intensity for LAM1 expression was observed at all concentration with molecular weight of 180 kilodalton. The LAM1 expression showed decreasing pattern at increasing chloroquine concentration. Thus, the result obtained indicate that the lysosome function was disrupted at increasing chloroquine concentration. Microtubule-associated protein 2 is the commonly used autophagy marker to monitor the amount of autophagosome formed in cell. Based on the densitometry analysis, band intensity for LC32 was observed at all concentration with molecular weight of 18 kilodalton. The LC32 expression increased as the chloroquine concentration increases. The increased amount of LC32 correlates with the accumulation of autophagosome due to the activity of chloroquine blocking the fusion between lysosome and autophagosome. Amyloid-Beta 42 expression were observed in two conditions in cell lysate, which represent the intracellular expression. Meanwhile, supernatant is the extracellular expression of amyloid-beta. In lysate, 70.5 micromolar showed significant increase, followed by 125 micromolar and 17.5 micromolar chloroquine concentration. Meanwhile, in supernatant, similar, the expression of amyloid-beta 42 was highest at 70.5 micromolar, followed by 17.5 micromolar and 125 micromolar chloroquine concentration. Chloroquine is cytotoxic to human brain endothelial cells, especially at higher concentration, with reduction of cell viability, vacuole formation, and cell shrinkage. Chloroquine did successfully inhibit lysosome function observed through lysosome and autophagy marker, with increment in LAM1 expression indicates disruption of lysosomal membrane, or known as lysosomal permeabilization, and decrease in LC32 expression indicates the accumulation of autophagosome in cell. Effect of chloroquine-induced lysosome dysfunction cause increment in amyloid-beta 42 expression in both intracellular and extracellular. Thus, further study need to be conducted to examine the effect of lysosome on the permeability of brain endothelial cells. This study was funded by Ministry of Higher Education Fundamental Research Grant Scheme. That's all from me. Thank you.